So here's the thing. If you thought AI was already moving fast, this week just kicked the afterburners on. Elon Musk finally dropped Grok 4, a multimodal AI trained on 100 times more data than Grok 2. He's calling it an intelligence big bang. It showed up an hour late to the live stream, but once it hit, Musk made it clear. This model doesn't just process text anymore. It sees, listens, reasons. He thinks it's smarter than most PhDs. Grok 4 is part of xAI's strategy to embed a reasoning-first AI directly into X, formerly Twitter, giving users a model trained not only on web-scale data, but also social dynamics, memes, and real-time discourse. According to Musk, Grok 4 isn't just multimodal, it's context-rich, faster in inference than Grok 2, and capable of handling dense audio-visual queries alongside text prompts. What really makes Grok 4 stand out is its native integration with Tesla's Dojo training infrastructure and access to real-time social data from X. This gives it an edge in terms of live inference and ongoing reinforcement learning in the wild, something few other models are doing at this scale. Elon hinted that future versions might evolve faster than GPT models due to continuous in-field feedback loops. It's early, but it's bold. But that wasn't the only seismic shift. While Grok 4 was walking onto the stage, Microsoft made Copilot Chat completely free for developers. OpenAI is quietly preparing to launch an AI-native web browser. Yes, a direct shot at Chrome. Perplexity released Comet, a radical new browser that doesn't just fetch web pages, it thinks and acts with you. And meanwhile, NVIDIA quietly passed $4 trillion in value. And that was just the first 24 hours. This week, we're not talking about features. We're talking about a full-blown platform shift. So let's break down what's really happening. Grok 4. Real-time AI systems, generative video in Google Photos, atomic simulation models from Meta, a literal AI tongue made of graphene, and compute farms big enough to power entire cities. This isn't hype. This is the infrastructure of AGI being laid brick by brick, right now. Let's start with something that looks simple but is quietly transformative. Google Photos. If you've ever tapped that little plus icon to make a collage or quick animation, you know how buried and basic it feels. But with version 7.36 for Android, Google is quietly rolling out a full-screen Create panel that brings all those tools to the surface. Collages, animations, those dramatic cinematic photos that fake depth and motion, all just a tap away. But here's the real kicker. Two unreleased features are sitting quietly in testing: photo to video and remix. These aren't just templates. They're generative video pipelines powered by Google's internal image models. Photo to video creates entire video sequences from your still shots. Remix reimagines and reshuffles your media using aesthetic cues and style filters. It's like having an AI editor inside your pocket. No official release date, but internal flags suggest we're weeks, not months, away. Once it lands, millions of users will have access to AI-powered video creation without even realizing what's under the hood. Now let's move into the developer world, because this is where the future of live adaptive AI systems is quietly being built. Google DeepMind just open-sourced GenAI Processors, a toolkit designed for organizing real-time data flows across AI systems. The concept is modular. Break down any kind of data, text, images, audio, even structured formats, into self-contained processor parts. Built on Python's Asyncio framework, these parts travel down an optimized pipeline where every stage can begin processing the moment the first byte hits. That means lower latency, faster time to first token, and a smoother experience for any kind of streaming interaction. What makes this especially powerful is how tightly it integrates with Google's Gemini models. It supports both standard API calls and the new Gemini streaming feed, which means you can start getting answers before you even finish asking the question. 3 demo notebooks are already out. One that turns raw sports data into live commentary, one that gathers and summarizes web content, and one that listens through a mic and speaks back. Think LangChain, but optimized for bidirectional, low-latency communication. Let's zoom out, like way out, down to the atomic level. Meta's FAIR lab just introduced a model family called YUMA, short for Universal Models for Atoms. It tackles one of the biggest bottlenecks in computational science: how to simulate atomic interactions quickly without sacrificing accuracy. Traditionally, researchers use density functional theory, DFT, to simulate molecular behavior. It's precise but painfully slow. YUMA changes the equation by training a massive graph neural network on 500 million atomic structures. Instead of solving equations, it predicts outcomes with near DFT accuracy in a fraction of the time. Even the smallest public version of YUMA can simulate 1,000 atoms at 16 steps per second on a single 80 GB GPU, and it can handle test sets of up to 100,000 atoms. The architecture uses a design called EEN, enhanced with inputs like electric charge, magnetic spin, and energy conservation constraints. Plus, it uses a mixture of expert system, with 8 subnetworks delivering optimal performance. Meta found that pushing past 32 didn't yield much more. The model has limitations, like struggles with atomic forces, beyond 6 angstroms or unseen charge dark spin configurations. But it's outperforming many models that were hand-engineered for specific tasks. And Meta is just getting started. Their roadmap includes flexible interaction ranges and new embedding strategies. This isn't just cool science, it's infrastructure for AI-driven drug discovery, materials science, and more. Yes, you heard that right. Scientists just built a graphene-based AI tongue, a literal taste sensor. It uses a stack of graphene oxide sheets, each only an atom thick, inside a nanofluidic channel. As liquid flows through, molecules interact with the graphene, subtly changing its conductivity. Each shift is like a musical note, a pattern, a signature. Those signatures get fed into a machine learning model, which has been trained on 160 different compounds, ranging from sweet and salty to complex flavor blends like dark roast coffee and cola syrup. The result? 98.5% accuracy on known flavors and up to 90% accuracy on entirely new ones. Even better, the ML model and the sensor live on the same chip. That eliminates latency, solves a major bottleneck in previous designs, and opens the door to real-time, embedded flavor detection. Yes, it's still a lab prototype, and yes, it pulls more power than a phone can handle. But once it's miniaturized, the use cases are clear. Taste restoration for stroke or COVID patients, spoilage detection in food chains, robot chefs that adjust seasoning on the fly. It's a literal sensory bridge between biology and AI. Now let's talk scale, like power plant level scale. Mark Zuckerberg just revealed that Meta's upcoming AI supercluster, codenamed Prometheus, will go live in 2026. It'll draw more than a gigawatt of power. To put that in perspective, a gigawatt is enough electricity to power 750,000 homes, and Meta wants that just for GPUs. They're not stopping there. A follow-up cluster, Hyperion, is projected to hit 5 gigawatts over the next several years. That's not a compute center, that's an industrial grid. The reason? Meta is building its own future for Llama 4 and beyond. The delays with Llama 3 Delta didn't sit well internally. the performance jump wasn't big enough. Prometheus is the fix. Zook's also pulling talent from the top. Nat Friedman from GitHub, Alexander Wang from Scale AI, and a rumored $200 million offer to Apple's generative AI lead. And the market? Not spooked. Meta's stock is up 25% this year, currently hovering just under 721. They're not just betting on AGI, they're building the grid to power it. So let's zoom out. This week we watched Elon drop Grok 4, Google embed video generation in your camera roll, DeepMind opened the door to real-time AI orchestration, Meta simulate atoms with a GNN, and scientists teach AI to taste. Meanwhile, companies are racing to build GPU clusters that could rival national energy grids. If you're still thinking AI is about chatbots and productivity tools, you're missing the real story. This is the emergence of new infrastructure, the plumbing of AGI, and we're watching it get built in real time. Let me know which breakthrough hit hardest for you. Drop your thoughts in the comments. And if you want more like this, deep dives without the fluff, you know what to do. Like, subscribe, and welcome to AI Ascension. See you in the next one.